So now that I've given you an overview of functional features, we've compared and contrasted object-oriented and functional programming, talked about how they work best when you combine them. The rest of this talk today, and possibly we'll cover a little bit more next time after we talk about Git, we'll focus explicitly on the Java 8 functional programming features, the foundational features, starting with Lambda expressions. And so we'll start off by talking about Lambda expressions, and I'll give you a bunch of examples to illustrate how Lambda expressions work. So what is a Lambda expression? A Lambda expression is an unnamed block of code that optionally could take parameters, depending on the signature involved. And you can take this Lambda expression, you can take a Lambda expression, you can take this unnamed block of code, and you can store it in a variable, for example, or a field. You can pass it around to a parameter, and you can execute it later in time. Those are the three key things you can do with a Lambda expression. To illustrate this, we'll take a look at the very, very simple example, the famous hello world example. And you can see here where we have a new thread that we're going to start to run in the background. And we're going to give the constructor of this thread an instance of a runnable. And that runnable, when run in the background thread, is going to print out hello world. So that's what we're going to do. That's what this program does. So let's kind of break this down a little bit. So the first thing you see is this somewhat weird syntax where we say OpenClosedParen, and that simply says that we're about to define a Lambda expression, an unnamed block of code, that takes no parameters. So OpenClosedParen just means no parameters are going to be used here. And then we have this arrow, and the arrow basically is just a little syntactic device that says what's about to follow is the body of the Lambda, and that's separate from the parameter list, which in this case, there were no parameters, so it's the null parameter list. And then comes the actual body, and that defines the computation that we want to have performed, which in this case, we're just going to print hello world. But of course, hello world will be printed in the background in a background thread. OK, so hopefully that's fairly clear. Not too syntactically jarring. And one of the nice things with Lambda expressions is they allow you to concisely express behavioral parameterization. Remember we talked before when I talked about some of the key concepts of functional programming, and we talked about things like, you want to be stateless, you want to avoid side effects, you want to do various things, relating to just getting to the essence of the computation as opposed to mutable state. And then I said, and you can also do behavioral parameterization. So behavioral parameterization is what this is doing. So lambdas give you concise and flexible behavior parameterization. As you can see, there's other ways of being able to do things with other techniques like values, and those are more verbose. And I'll show you an example of this in just a second. So once we've got our little constructor, which is a Lambda expression, we can go ahead and create our thread object with that Lambda as a parameter, and then we can start it. And as you probably know, maybe you know, that will cause a new thread to be created, and the thread will have its own runtime stack, so it'll go ahead and execute hello world in the context of this background thread in a separate Java thread. You can also take a Lambda expression, like we had here, and assign it to a field or a local variable. So we could say runnable r equal Lambda expression, and then we could say new thread r dot start. So that's just a shorthand way of doing this. And the typical reason you would do this is if you wanted to reuse the Lambda expression in multiple places, rather than having to type it out laboriously over and over again, you could store it into some field or some variable and then just pass it in, and you might pass it multiple places. So that's just a way of kind of shorthand, lexical shorthand. Lambda expressions are really nice because they're very compact, and they only focus on the computation or the computations that you want to perform. They don't have much, if any, extraneous syntax. Well, what are we comparing that to? What's the baseline for comparison? Well, here's the baseline for comparison. This is the old way of doing things with so-called anonymous inner classes. This is the way you used to have to do behavioral parameterization in Java before Java 8. And so what you would do here is you would say new runnable, open close paren, open curly brace, public void run, open close paren, open curly brace, system.out.println hello world, close curly brace, close paren. I think you'll agree with me that that's rather ugly and tedious to have to type this stuff out. So it's a lot more typing and just a lot more syntax. Whereas what we really want is something that just gets to the computation and doesn't distract us with all this additional syntax. Let's take a look at an example here that's a little bit more interesting than hello world that demonstrates Lambda expressions and also shows how you can use them with multiple parameters. So in this case, we're going to have an array of names. So you have an array of names that are represented as strings. So you have a string array called name array. And I'm going to show you two different ways to sort the contents of this string, or these array of strings. The first way here is to use the classic anonymous inner class. So you say new comparator, string open close, public int compare, string s, string t, return s.to lowercase, compare to t.to lowercase. Boy, is that distracting, right? So that's kind of the Humvee, gas guzzling, environmentally unsustainable way of programming your code. In contrast, the much more lightweight, lean approach is to use a Lambda expression. So that's more like this little smart car. So we say arrays.sort name array, and then we say comma, open paren s, comma t, close paren, arrow. And this is basically just saying these are two parameters, and they turn out to be of type string. I'll explain that in a second. Take these two parameters and then compare them in a way that ignores case. So uppercase and lowercase are treated the same for sorting. And here's another interesting little tidbit. This s comma t is actually shorthand for string s comma string t. And what happens here is that this shorthand version leverages Java's type inference capabilities. The compiler can now deduce that this is an array of strings, and therefore s and t must be strings. Because it's an array of strings, we're going to be sorting by comparing strings. So I think you'll agree with me that this is a lot more concise. And it's concise because it omits the name of the method, and it also gets rid of all this other extraneous syntax that otherwise is very distracting and tedious. So it's a good idea whenever possible to use, use Lambda expressions, not method references. It's a good idea to use Lambda expressions wherever you can. And I'll show you soon why it's also a good idea to use method references wherever you can too. But that's the next example we'll look at when we talk about method references. Some other cool things you can do with Lambda expressions, you can actually have the Lambda expression access variables from the scope in which the Lambda expression appears. And these are called effectively final variables, and I'll talk about what an effectively final variable does in a second. So here you can see we have some local variable answer, which of course has the magic number 42 from the Hitchhiker's Guide to the Galaxy. We then make ourselves a new thread, and here we're going to say the answer is plus answer. So this is concatenating the value of answer into this particular string. And notice that this is a Lambda expression, and in fact that Lambda expression is going to actually run in a thread in the background. So it's a very different context from where this is defined. And because of the magic of something else that was added in Java 8 called effectively final variables, we can actually access the value of answer in this Lambda expression that runs in a background thread, and it works perfectly correctly and safely. An effectively final variable is simply a variable whose value doesn't change after it's initialized. So it's not final. We don't say we don't have final int answer. We could say final int answer, but we don't have to. But this is effectively final because it doesn't change between the point where it's assigned and the point where it's actually used. Lambda expressions are most useful when they're stateless and have no shared mutable data. So remember that shared mutable data, shared mutable state is the root of all evil. You can read this article for more information about why that's the case. And that's because they lead to race conditions. So we like to use stateless Lambda expressions. That's the great way to go. Stateless Lambda expressions are particularly important when we start programming parallel streams, where you've got this composition, this pipeline of functions that work on their input, do some computation, produce output, and then that gets kind of piped into the next operation in the chain, in the pipeline. And when we talk about that, you'll see how having stateless Lambda expressions are great, because then all these threads can run in parallel, and we never have to worry about corrupting state. We never have to worry about synchronizing anything. It all works great. So we'll talk more about that when we get to parallel streams a little later in the course. Something else I want to talk about briefly here, because it's pretty cool, is how you can use Java 8 Lambda expressions to implement variants of so-called closures. So closures are a very interesting feature that are found commonly in functional programming languages. A closure is an object that stores a method together with an environment that has at least one so-called bound variable. So here's an example. We'll take a look at this. Here you can see we have a class called closure example. It's got a private field called mres for mresult. It's got a method called makeThreadClosure that takes a couple of parameters, string s and int n. And you can see it's going to create a new thread that, in the background, will print out s, whatever s is, plus mres plus equal n. So it turns out that mres and s and n are all bound variables. And a bound variable is simply a name that is associated with a value, such as a number or a string, as you see here. So we're going to use this to create a closure. And this Lambda implementation, this Lambda expression implements a closure that captures the value of this private field and the method parameters that are passed to the makeThreadClosure factory method. Now, here's the interesting little trivia thing. This is why Java 8 Lambda expressions are not quite as powerful as arbitrary closures. The constraint is that parameters or local variables in a closure must be read-only, so you can't change them. However, private fields can be updated. So you can update a private field, but you can't update the values of parameters or local variables. That's really one of the things that makes Lambdas not quite full-blown closures, but they're pretty good for most usual cases. So what we do here, here's the constructor for this example. You can see that we make the thread closure, passing in the string s and the value n as 10. So the string says result equals, and we pass in n. And then that will go ahead and create a thread, which we will start. And when we start the thread, it's going to print out result equal 10 plus equal whatever mres is, which starts with 0, so it'll be 10. But it'll update mres to 10, right? So it'll update it. So if we called it again, it would get the value 20 next time if we pass the 10 in. And then we go ahead and join. And join is simply a barrier synchronizer that says, wait for this thread to finish running before continuing the program's flow of control. So we go ahead and start things, and they run. So that's basically illustrating Lambda expressions. And Lambda expressions are very powerful, very common, and you'll get a chance to program them quite a bit in the course as we go through it.